Hey there, it's Max Doolin, and this is the EVM Challenge 2 for the 6th year of the Spokane Cyber Cup. In the previous challenge, all we did was make a call to the smart contract, and this was meant to be a sanity check for the students. In this challenge, the students are going to have to write a really simple smart contract and have it get called by another smart contract. So we'll read the prompt. In the previous two challenges, I need to fix that. This was originally the third challenge. So in the previous challenge, you only had to call the smart contract. Now you need to create a smart contract and have it be called by another smart contract. The deployed program, call me, will call your smart contract function's callee. When it's called, it returns a uint256. Your smart contract should return a value of 17. To solve the challenge, use the function callu on the smart contract with your input contract as a parameter and have your smart contract return 17. If you are successful, the win function will return true, which can easily be checked by you as a sanity check, but then you want to go back to the website to get the flag for that. So speaking of that, we can go back to the website now. We want to go to the second challenge, call me maybe. So of course I want to create a smart contract instance. So this will deploy a unique version for our particular user going through this. Now if we go to here, we don't need this call contract anymore. We just need the call me contract. For our own sanity, we want to put this at a particular address so we can see what's on it. So we can see we didn't win and success is currently set to false. Cool. So one may wonder what this code looks like. We can go through it. So here is the function callu. It has a interface called call me later, and this is casting the address that we're providing to a call me later type, and then is calling the function callee on that. It is expecting to have a uint be returned and the result be equal to 17. If all that works out, then the call did succeed. And if the call succeeded, then win should succeed as well. So there's some new concepts here. First is an interface. An interface is fairly common in smart contract programming where, and actually most programming languages in some capacity, where it is a general descriptor or template for how you think some code should look. And you can do this this is nice to have, because there are situations where you don't know exactly what version of something you're calling. With like polymorphism, for instance, you may not know the exact version, but you want things to conform to a certain standard, and interface is a good way to do that. So we need to write a smart contract that's going to return the value of 17 for us. And when it returns the value of 17, we can then, it will return success. So we're going to have a contract called solution. And we don't have to use this technically speaking, but I think it makes it easier to see. We just need a particular function called callee that has this information on it. So you notice this will say, hey, you haven't marked this as abstract because you're missing an implementation. So this is erroring because we don't have this function in there. So if we add this function, it will then say, hey, we're good. You've done your job here. Now, what this function is saying is the function's name is callee, is an externally callable contract, and it returns a type of uint256. In Solidity, uint and uint256 are complete aliases of each other. So all I have to do now is return 17. So here, if I pass in a random value, for instance, this account, and do callu, this will fail, even if we force send the transaction. So we see here that there's a big red X. I gotta say, Remix is not the best about giving you good error messages. It just says that this thing reverted, and it doesn't really tell us why. students are probably going to run into this a lot. So it's really important to be very pedantic when you're looking at all this stuff. Am I on the right HTTP provider? Am I calling a legit contract? A lot of smart contract stuff is just doing analysis on the stuff you're doing, kind of executing in your head and thinking about it, because debugging is a real pain in the butt. So, with that in mind, we're going to deploy our new contract solution. We call it deploy, and now we have our own contract here. So in this case, we have call E that we want to return a value. And unfortunately, I actually made a mistake on this interface. So in Remix, it won't return and show you the value unless you have a view. So I think you need to do external view is what that actually should be. So now I can do external view. And if I delete that deployment and redeploy it, you'll notice that it does indeed return 17. So we've successfully deployed a smart contract called solution that, when called with the function callee, returns a value 17. That is exactly what we need for this challenge. So now we're going to copy that contract address, and we're going to call u. The way this works is call u takes in the address A. It's going to typecast to a call me later type. It's going to call the function callee on it, which will then go here. Callee will return 17, which then will be verified here correctly, and all will be good in the world. So if we do call u and we do success, it now returns true, and if we check true in this case, it won. So we can go check the flag if we want, but I want to show you guys something real fast, just to prove that this return value is really important for this. If we do a deployment now of this version of it, which if we look, I deployed the wrong contract. If we deploy solution again, and we look at callee, this now returns 16. So we're going to copy that contract address, go into call me, and this will fail because we're not returning the value of 17. Now, smart contracts are completely atomic when they're executed, meaning that it's all or nothing. Either the state happens or it doesn't. So because this fails at that point, that means that all of the previous state updates and writes are completely changed back to the original one. And this is called a revert. And this error is actually a lot nicer. You'll see here that we actually have wrong return value, which is what this equals. In the case of calling a non-existent contract, it gives you a bad error message, though. So now if we call submit, we'll get the flag, because when this function on the back end calls win, it returns the proper value. So hope you learned some good stuff about smart contracts and had a good time doing it. See you in the next video.